Next example on the greatest common divisor and equivalence lemma. So what is the example? If A and B are relatively prime and B divides to AC, then show that B divides to C. So A and B are relatively prime means their greatest common divisor is 1. So this is another form of this equation, that A, B, C are integers such that A divides to B, C. A divides to B, C. And greatest common divisor of A and B is 1 means A and B are relatively prime. One and the same, both sentences are same. A and B are relatively prime means greatest common divisor of A, B is equal to 1. So these two things are given, that greatest common divisor of A, B is 1 and B divides to A, C. So one by one we write the meaning of the given. So given is what? A divides to B, C and greatest common divisor of A, B is 1. And greatest common divisor of AB is 1 means there exist two integers, either x and y, write x and y, use letter x and y, or m and n, such that 1 is equal to ma plus nb, or ma plus nb is equal to 1. Because the greatest common divisor of, suppose greatest common divisor of A and B is D, then D is expressed in the form A into some integer, that is x or m, or and B plus B into y or y, n. So 1, the greatest common divisor of A and B is 1, and therefore 1 expressed as in the form MA plus NB. So write 1 is equal to, or MA plus NB is equal to 1. Then multiplying by C, what do we have? MAC plus NBC is equal to C, multiplying this equation by C. And also write the meaning of A divides to BC. A divides to BC means BC expressed in the form A into some integer. So right here BC as AK. What is, why BC is AK? Because right here the meaning of A divides to BC, right here that A divides to BC, therefore BC expressed in the form A into some integer, A into some integer, suppose that integer is K. So write BC as AK and then take A as common. So what do we have? C is equal to, suppose this is X, NC plus NK is X. Then C expressed in the form A into some integer, and therefore A divides to C. So write this right side to the left side and left side to the right side. Then C is equal to X, that is C expressed in the form A into some integer, and therefore A divides to C. So this is also an important example, like it is in the exam March 10, March, April 13, and all the examples on the Euclid's lemma are important. So next is the definition of composite number. The number is called composite number if it is not prime number. So very simple definition, and that is it expressed in the form m into n, where m and n are both are greater than 1, obviously. So it is expressed as a product of two numbers greater than 1, or the number are not prime, then are called prime, are called composite number. Obviously the numbers are greater than 1. So these are the prime numbers 2, 3, 5, 7, 11. And so what are the numbers? Composite numbers 4. Between 2 and 3 there is 4. 4 is composite number. Between 3 and 5 there is 4. And between 5 and 7 there is a 6 number. Okay, that is composite. Between 7 and 11 there is number 8. Also 9 is also composite number, 9. Because it is not prime. 9. 10. These are the composite numbers. Okay, so the definition of composite number. Next is the example, that write these two numbers in canonical form and find their greatest common divisor, and means GCD and LCM. LCM means least common multiple. So what is the formula to find least common multiple? Either find the greatest common divisor of these two numbers and use this formula, that this is the notation for least common multiple, square bracket A comma B. Square round bracket A comma B means greatest common divisor of A and B, and the square bracket A comma B means the least common multiple, LCM. This is the notation for LCM. So find LCM by using this formula, that is find greatest common divisor of two number and divide this number mod A into B. What are A and B? A and B are given numbers. So mod A into B divided by greatest common divisor. This gives the least common multiple, LCM. Or separately we can find the LCM by using a canonical form, that is express the numbers into as a product of prime numbers. So we have to express this a, suppose a is 819 and b is 658, then we have to express these numbers as a product of primes. So a is equal to, so divide first by 2, but 2 is not divisor. So then divide by 3. So 3 into 8, 3 divided by 8, 9, 819. That is again divide by 3, divided by 7, divided by 13. In this way, we have the canonical form, that 3 raised to 2, 7 raised to 1, 13 raised to. No need of writing for 3, 7 raised to 0 or 2 raised to 0. 3 square, 7 raised to 1, 13 raised to 1. This is the canonical form of 819. And then canonical form of 658 is this: 2 raised to 1, 7 raised to 1, 47 raised to 1. And so what are the common factors? What are the common factors between these two? Is the greatest common divisor. So 2 raised to 2 is not common, 3 is not common, 7 is common. So 7 raised to 1 is common. Then 13 is not common, 47 is not common. So 7 is the greatest common divisor of these two numbers. So we can also find the greatest common divisor of these two numbers by using Euclidean algorithm. But here is the instruction that write this is in canonical form and then find greatest common divisor. So write canonical form and then find greatest common divisor. This is the notation for greatest common divisor, round bracket a comma b. And then LCM. What is the LCM of these two numbers? So write common factors first, write common factors and then uncommon factors. What are the uncommon? 2 raised to 1 is uncommon, 3 raised to 2 is uncommon, 7 is common. So write only one time 7 common. Take common as a one single time. Okay, and then 13 is not common, but 13 is uncommon. So write 13 raised to 1, and 47 raised to 1 is uncommon. So multiplication of all these numbers, that is this number, is what? LCM of the two numbers a and b, and this is the notation. Or we can use this formula, that is write LCM of a and b is equal to mod a into b, that is mod 819 into 658. Mod gives the positive sign only, divided by greatest common divisor, divided by 7. We get this answer. Okay, so this is the greatest common divisor and LCM of the two numbers. So if you have to find the LCM of two large numbers by using Euclidean algorithm, then find first the greatest common divisor of that two numbers and use this formula to find LCM of two numbers. So in order to find LCM of large number, we find first the greatest common divisor of that two number by using Euclidean algorithm and then use this formula to obtain LCM of the two numbers. So next example, p is prime such that p divides to a and p divides to a square plus b square, then show that p divides to b. So suppose p divides to a, this is given, p divides to a and p divides to a square plus b square. Then what happens? P divides to a, therefore p divides to a square obviously. And p divides to a square plus b square. These two sentence indicates p divides to a addition of these two number or subtraction of these two number, a square plus b square minus a square. Because if p divides to x and p divides to y, then p divides to x minus y. Suppose p divides to, this is x and this is p divides to y, then p divides to x minus y by using the properties of the divisibility. And this we have the p divides to b square, and therefore p divides to b square means p divides to b and b into b. P divides to b into b. P divides to b square means what? P divides to b into b. And p is prime. And we know that the Euclid's lemma is what? If p is prime and p divides to a into b, then either p divides to a or p divides to b. Here we have p divides to b into b, means by Euclid's lemma what we have? Either p divides to b or p divides to b. That is, both sentences are one of the sentence is true, that p divides to b or p divides to b, but both sentences are same, and so ultimately we have p divides to b by Euclid's lemma, because p divides to, what is Euclid's lemma? If p is prime and p divides to a into b, then either p divides to a or p divides to b. One of them is true. But here p divides to b square means p divides to b into b. And then what do we have by Euclid's lemma? Either P divides to B or P divides to B. One of them is true. And if any one is true, then ultimately we have P divides to B. The next example, find all primes which divides to 50 factorial. So what is 50 factorial? The multiplication of all natural numbers from 1 to 50. That is 1 into 2 into 3 into 49 dash 49 into 50. This is the 50 factorial. That is the multiplication of all natural numbers from 1 to 50. And the number of primes dividing 50 factorial will be nothing but the number of primes less than 50. So the number of primes dividing 50 factorial will be nothing but the number of primes less than 50. So when the prime divides to 50 factorial, if prime divides to this number, that prime divides to, suppose P is the prime and that divides to this number, that is the multiplication. When we say the prime P divides to this number by using Euclid's lemma, corollary on Euclid's lemma, then when we say P divides to this number, if one of them, P divides to one of them. Okay, and so this sentence that the number of prime dividing 50 factorial will be nothing but the number of primes less than 50. That is, just find numbers less than 50, and that are the numbers dividing 50 factorial. So what are the numbers less than 50 and are prime? So start from 2. One is not prime. So we have to find the numbers less than 50. We have to find the numbers which are primes and less than 50. So what are that numbers? 2, 3, 5, 7, 11, 13. So like the least up to 50, all like the list of primes up to 50. So these are the numbers less than 50, and these are the primes, so less than 50. And these are how many in numbers? 15 in numbers, which are 15 in number. And therefore the answer of the question is what? Find all primes which divides 50. So these are the primes. These 15 primes are the divisors of 50 factorial. So next example, show that root 7 is not rational number, or show that root 7 is a irrational number. What did they say? That show that root 7 is not rational number means show that root 7 is irrational number, because the number is not rational, then number is called irrational number. So we have to show the number is not rational number or is irrational number. So we have to show that root 7 is not rational number. The proof is by contradiction method. We assume that, suppose that root 7 is a rational number, and if we have some contradiction, then we say this statement is wrong means root 7 is a rational number, is wrong means root 7 is not rational number. So this is the procedure of method of contradiction. That is, we assume the given statement is wrong, or we assume the negation of the given statement. So we have to show root 7 is not rational number. We assume that, suppose that root 7 is rational number. So root 7 is rational number means root 7 expressed in the form P by Q. Because we know that the definition of rational number, a number is called rational number if it is of the form P by Q or expressed in the form P by Q. For example, 3 by 2 is rational number. 5 by 9 is a rational number. 5 is also rational number, because 5 you can write 5 in the form 5 by 1. 10 is rational number, because we can write 10 in the form 10 by 10 as a 20 by 10, or we can write 10 as 10 by 1. Then 5.2 is also rational number, because we can write 5.2 in the form 52 by 10. Okay, but this 52 by 10 is not its smallest form. For example, if we write, how can we write 4 is in the form of P by Q? We can write 4 in the form of the form P 4 by 1. Okay, or we can write 0.5 is also rational number. How we can write 0.5? 0.5 as a 5 by 10, or we can write 1 by 2, that is 1 by 2 is zero point 0.5. 3 by 6 is also the form of p by q form of zero point 0.5. But what is the lowest form of 0.5? It is 1 by 2, because the greatest common divisor of 1 and 2 is 1. uh, 5 by 10 is not greatest common, is not smallest form of zero point 0.5, because the greatest common divisor of 5 and 10 is 5. So we assume that this root 7 is rational number. Therefore root 7 expressed in the form p by q, where obviously p and q are integers. This is in the definition of rational number. And we assume this p by q, greatest common divisor of p and q is 1, means this p by q is in its smallest form. Okay, and then what do we have? 7, squaring both sides. So what do we have? 7 is equal to p square by q square, and then p square is what? 7 into q square. And this p square express, this q is integer, means q square is also integer, and therefore p square expressed in the form 7 into some integer implies 7 divides to p square, because p square expressed in the form 7 into some integer, and therefore 7 divides to p square. And then by Euclid's lemma, 7 is the prime number. So what do we have? 7 divides to p into p, and therefore we have by Euclid's lemma either 7 divides to p or 7 divides to p. And that is ultimately we have one sentence is true, but any sentence is true, then we have 7 divides to p. Because what is the Euclid's lemma? If p is prime and p divides to a into b, then either p divides to a or p divides to b. Here 7 is prime, and 7 divides to p into p means what we have? Either 7 divides to p or 7 divides to p. That is ultimately we have 7 divides to p. And 7 divided to p means p expressed in the form 7 into some integer. So suppose there is r in z such that p is equal to 7 into r, then squaring both sides, so we have p square is equal to 49 r square. And then write this p square as a 7 into q square, and this value of p square as 7 into q square. So 7 into q square is equal to 49 r square, and then divide both sides by 7. We have q square is equal to 7 r square, and this implies 7 divides to q square, because q square expressed in the form 7 into some integer. This r square is integer because r is integer, and this implies 7 divides to q square. And this implies by using Euclid's lemma that 7 divides to q into q implies 7 divides to q or 7 divides to q. That is, we have the 7 divides to q by using Euclid's lemma, and then q expressed in the form 7 into some integer. Suppose r1 is that integer, for some r1 belongs to z. And so from these two, that is from 2 and 4, this 2 and 4, what is the 2? P is equal to 7r, and what is q? Q is equal to 7r1, that is p expressed in the form 7 into some integer, q expressed in the form 7 into some integer, and therefore the 7 is the common divisor of 7 divides to q as well as 7 divides to p, means 7 is a common divisor of p and q, and therefore the greatest common divisor of p and q is what? Is either 7 or greater than 7, because 7 is the common divisor of p and q, means 7 becomes a greatest common divisor. When 7 becomes greatest common divisor of p and q, is 7 is greatest among all common divisors. But the greatest common divisor of p and q is not less than 7, because 7 is a common divisor. If 8, suppose 8 is common divisor other than 7 of p and q, then greatest common divisor of p and q becomes 8. Suppose 11 becomes 11 is the greatest common divisor, is a common divisor of p and q, then 11 becomes a greatest common divisor. But suppose 6 is the common divisor of p and q, then 6 is not the greatest common divisor, because 7 is already common divisor of p and q, means either greatest common divisor of p and q is 7 or larger than 7, number larger than 7, but number less than 7 are is not greatest common divisor of p and q. If it is common divisor, then also it is not a greatest common divisor, because 7 is a common divisor, means greatest common divisor of p and q is greater than or equal to 7. But this is which is contradiction to the fact that greatest common denominator of P and Q is 1. Here is P and Q are is in smallest form. So greatest common denominator of P and Q is 1, and therefore this is wrong. This is a contradiction to the fact that greatest common denominator of P and Q is 1, and therefore this is wrong. uh, we have the contradiction, means root 7 is a rational number. This is wrong, means what do we have? Root 7 cannot be a rational number. Root 7 is not rational number. This is wrong. Our assumption is wrong. Why we have the contradiction? Because our assumption is wrong, that root 7 is a rational number is wrong, means what is correct? Root 7 is not rational number. That is, root 7 is irrational number. So remaining problems we will see in the next lecture.